Hi everyone, welcome to fifth help session of the course E220. Today we are going to solve two problems. This is the first problem. Determine the value of power supplied by the dependent source in the figure below. Here we can see this dependent source. We have been asked to compute the power supplied by this dependent source. And in order to compute the power supplied by the dependent source, we need source voltage and current coming out of this positive terminal of the source. So for voltage, we need IA, and for current, we can apply any approach. Since no approach is specified here, we can use either mesh analysis or nodal analysis. In this particular problem, I'm going to apply nodal analysis. So while applying nodal analysis, I've created three nodes, 1, 2, and 3, and this node has been grounded, and so its voltage is 0, and we need to compute this current coming out of the positive terminal of this dependent source. So let's see at node 3. Since node 3 is connected to the positive terminal of this 10-volt source and its negative terminal is grounded, so we can easily write V3 equals to 10. Now, between node 1 and 2, we can see that there is a voltage source. So here also we can write V1 minus V2 equals to 8IA. So V1 is at the positive terminal. So positive terminal minus negative equals to 8IA. Here we have to substitute this V1 and V2 in terms of IA. So here we know that IA is the difference between voltage. IA is the current through 16 ohm resistor, and the voltage across this resistor is V2 minus V3. V3 here is 10. So V2 minus 3 divided by 16 will be the current. So V2 minus 10 divided by 16. After further simplification, we can write in this way. This is the equation 1. Now let's apply KCL at this supernode 1 and 2. A supernode is formed out of this nodes 1 and 2, since there is voltage source in between them. So let's apply KCL at supernode. While applying KCL at supernode, let's assume all these current through this resistor, this resistor, this resistor, and this resistor. Let's assume all the currents as outgoing currents. So if we do so, for this branch, the current will be V1 by 12. For this branch, current will be V1 minus V3 by 4. V3 equals to 10. So the second term. For this branch, V2 minus V3 divided by 16. V3 here is 10. So it's here. For this branch, V2 divided by 8. So after further simplification, we get this equation 2. Now, if we solve this equation 1 and 2, we get these values of V1 and V2. Since we got the voltage of V1 and V2, now we have to compute IA and current coming out of this positive terminal of the source, dependent source. So we can easily compute IA. IA can compute as V2 minus V3 divided by 16. V3 here is 10. So we can easily compute IA. So let's assume this current I be the current coming out of the positive terminal of the dependent source. Then we can determine this current by applying KCL at node 2. Let's apply KCL at node 2. If we apply KCL at node 2, then we can see that this outgoing current is I, this outgoing current IA, and this outgoing current here is V2 divided by 8. So all our outgoing current, incoming current is 0. So now if we plug in values of IA and V2 here, which is all determined, we can easily compute I, and I equals to this. Now the power supplied by the dependent source is given by P equals to current times voltage, right? So current coming out of the positive terminal is I, and its voltage is HIA. So now we got P equals to 1.033 watt. Let's move to our second problem. Find the value of voltage measured by the voltmeter in the figure shown below. Here we have to calculate the voltage measured by this voltmeter. The voltmeter here measures the current, voltage across 2 ohm resistor. And in order to compute voltage across 2 ohm resistor, first of all, we need to let's find the current flowing through 2 ohm resistor. And 2 ohm resistor and 3 ohm resistor are in series, so same current flows through both of these elements. So in order to compute current or voltage across 2 ohm resistor, we can use any approaches, but here I'm going to use nodal analysis. So let's consider this as grounded node and this node 1. So let's start by applying KCL at node 1. When we apply KCL at node 1, let's assume this current is outgoing and this current is also outgoing and this current is itself outgoing. We don't need to, and so incoming current are 0 and outgoing current through each of these 3 branches we should consider. Here, outgoing current through this branch is V1 minus 9 divided by 4. This is outgoing current through this branch, and this outgoing current 3 by 4, second term. And for this branch, V1 divided by 3 plus 2 equals to 5. So after further simplification, we get this. And then after further simplification, we get V1 equals to 10 by 3. Now we obtain V1. So using V1, we can obtain current through this branch. So let's see the current through 2 ohm resistor. Current through 2 ohm resistor or 3 ohm resistor is same, they're in series. So current through 2 ohm resistor equals to V1 divided by this total resistance, V by R. Total resistance 5, so we obtain Q by 3. Now voltage measured by the voltmeter, which is also equal to voltage across 2 ohm resistor, will be equals to V equals to I into R. I is 2 by 3, R resistance is 2. So we have obtained V by 3. Okay, thank you for watching the video. See you later in next help session.